All right, so in this lab, we are going to be setting up a spanning tree protocol, which is enabled by default, but we're going to make some configurations and changes to it in the switching domain that you see here in the topology. And we're also going to implement some switching domain security. Basically, after going through spanning tree protocol, building the configuration, we're going to implement what's called a bpdu guard and spanning tree root guard, in addition to shutting down unused ports. And just as a refresher, we'll configure one port with port security so you get the idea of how you would want to implement port security on access ports. So basically what spanning tree protocol is in a nutshell is when you have a switching domain and you see four switches here with dual connections connected over trunk links, is how do the switches exchange information with one another in this domain, i.e. their MAC address tables. So when for example, when PC4 and VLAN 5 wants to ping PC2 in the same VLAN, right? What does the switch use to determine to send that frame over to the PC2 on VLAN 5, right? So they just, I guess a good analogy is just like routers share routing information on regarding networks, switches in a switching domain share MAC address information in a switching domain. And so what you need is in these advertisements is to prevent endless loops. In other words, switch one could advertise its MAC address table to switch 2, and then switch 2 could advertise switch 1's and switch 2's MAC address table to switch 3, and switch 3 could take switch 1's and switch 2's and its MAC address table and send it over to switch 0, and then switch 0 could take switch 3, switch 2, and even switch 1 and advertise it back to switch 1, and then you get this endless loop, right? So spanning tree is the concept of electing a root switch and enabling some ports to be blocking. And this blocking of certain ports will prevent the endless looping. And you'll have a root switch in which all switches in the device communicate to. Okay, it's analogous to you go to a meeting and a project is being discussed and you got 10 people in a room, right? Well, somebody needs to be in charge, right? You can't just have everybody equal and just talking amongst each. Somebody has to be in charge to set the agenda, to set the discussion, right? The meeting times, project due dates, again, timelines, and manage all that. And a root switch is analogous to something like that in a switching domain where the root switch, like if you have a change to your topology, if you're switch 3, you'll send it to the root switch, and the root switch will send that throughout the switching domain, and it's done in a manner to prevent these endless loops that we talked about earlier. Okay, so what we're going to do is, the first thing we're going to do real quick is we're going to build this configuration, right? And we did this in previous labs. We're going to build it again, and then we're going to take a look at the spanning tree topology and look at which switch is the root. How do you determine which switch is the root? And what is meant by root ports, designated ports, and blocking ports, okay? And also, what is bpdu guard, what is root guard, and go over those two terms as well. All right, so let's just go ahead and get started with the lab. There's various ways to do this. Now, if you want to see your port connection settings, I can explain it to you as far as what ports are being used for what, but in the topology, the gigabit 01 port is going to be used to connect to router 0. Okay, and since that port will carry traffic for more than one VLAN, we'll set it up as a trunk port. Okay, ports 1 and 2 and 3 and 4 and this is throughout all switches, will be used as access ports. Okay, so we'll set up, excuse me, they'll be set up as trunk ports. So on switch 1, for example, port 1 and port 2 is connected to switch 0 on port 1 and port 2. And then on switch 1, port 3 and port 4 is connected to switch 2 on port 3 and port 4. And then on switch 2, ports 1 and 2 are connected to switch 3 on ports 1 and 2. And then on switch 0, ports 3 and 4 are connected to switch 3 on ports 3 and 4. So we just set up all those ports as trunk ports, ports 1 through 4, and we can use them. We can use the interface range command to speed up the process of configuring the ports. Now, as far as access ports are concerned for PCs, right, port 5 will be designated for VLAN 5, and port 6 will be designated for VLAN 6 on each switch respectively. Okay, so we can speed up some of this process. Okay, so I'll give you an example of how we can speed this up instead of repeating commands over and over. Let's go on to switch 1 though, and let's type enable config T. Now if I type CONF and just hit enter twice, same thing. I can go to that gigabit port, interface G0/1, and I can type the switch port mode trunk command. Okay. Just take us back to global config mode. And then what I'm going to do is open up a notepad document, because kind of explain how we could speed up the config. Okay, so what I'm going to do is I'm going to use the interface range command for ports 1 through 4, and you can type it in just as you see it here. Okay, and let me zoom this in a little bit bigger so you could actually see it. Okay, and then from the interface range command, these are trunk ports, so we type switch port mode trunk. Okay, and then we do the interface port 5, switch port mode access. We type switch port access VLAN 5. Okay, and we do that for port 6. Now, you know what? We'll do port security as well. Switch port dash security. And then we'll type switch port security, MAC dash address sticky, switch port security. We'll key in max. Maximum addresses, we want 1. MAC addresses, and then we'll hit enter. And then we'll specify the violation mode. And we'll type in protect, which won't entirely shut the port down, but will prevent it in a blocking state if an unauthorized MAC address connects to it. Okay, and then from there, I'm actually going to do the same thing for port 6. And I'm going to do this on each switch. So I'm just going to copy this because I only need to change the port number. So I go here, I change the 5 to a 6 here, and a 5 to a 6 here. Okay, so that configures ports 1 through 4 for trunking. Port 5 assigns it to VLAN 5 with port security, and then port 6 assigns it to VLAN 6 with port security. All right, so what I'm going to do is just copy all this. And I can go to each switch. Okay, I'll go to switch 1. And we'll just go ahead and paste that all in. We'll just go paste and hit enter. And go to switch 0. Hit enter. And don't worry about these spanning tree blocking, inconsistent port type states. We haven't fully converged with the spanning tree protocol. So you're going to get these error messages. So you got to go to global config mode. On switch 0, you got to right click and go paste, hit enter, and go to switch 3 at the bottom, hit enter, And you got to go to global configuration mode. See, so we're really kind of speeding up the configuration process here. And I'll go enable, config T, and I'll right click and go ahead and just paste that in, hit enter. Okay, so that completes the basic configuration for the switches. And instead of assigning IP addresses to the PCs in VLAN 5 and VLAN 6 on 4 switches, what I'll do is I'll set them up as DHCP clients. Or we'll set them up as DHCP clients, and we'll set router 0 up as a DHCP server. Okay? And I'll give you an idea how that looks, right? When we go to PC4 and VLAN 5, for example, you see they're set to static addresses. Okay? So what we'll do is we'll configure the router, okay, remember, we have to create sub-interfaces on the router for VLAN 5 and VLAN 6 respectively. And the address assignments we'll use is 10.0.5.0 /24. The gateway will have the first IP address, so it'll be 5.1 and 6.1. And you can see from these address assignments, we're using the third octet, 5 and then 6, to represent the VLAN. Later, we'll configure a management VLAN for the switches using VLAN 90. We'll do that when we're just about done with the lab. Okay, so let's go ahead and get started. We'll click on router 0. And we'll type NO, hit enter twice, and we'll go enable, and then config T. And then from here, we will go ahead and go to our interface. I got to remember the interface. There it is, G000. And remember, when you're configuring sub-interfaces, the only thing you do on the interface is turn it on with the no shutdown command. Okay? And then you configure your sub-interface. You go INT G0/0/0/0.5 to represent VLAN 5. And then we'll set the encapsulation, the trunking encapsulation protocol to .1Q and assign it to VLAN 5. And then assign the IP address. So we type IP ADD 10.0.5.1, 255, 255.0, and hit enter. Now we can cheat and hit the up arrow. All right, so we can hit the up arrow once, twice, 3 times, and change the interface from a .5 to a .6. Hit enter again, and hit the up arrow 3 times, and change encapsulation .1Q5 and change the 5 to a 6 and hit enter, and hit the up arrow 3 times and change that IP address. Position the cursor right after the 5, hit the backspace key, and you'll change it to a 6. Okay, and that completes the address assignments on the gigabit port, okay, the sub interfaces. Now what we need to do is set the router up as a DHCP server so we don't have to manually assign IP addresses to APCs, right, on this infrastructure that we have right here. So to do that, we type exit, and we'll create our first pool for VLAN 5. We type the command IP space DHCP space pool space, and we'll give it a name of VLAN 5 without any spaces between the N and the 5, and we'll hit enter. Okay, and then we'll assign the network address, and the network address is 10.0.5.0. Type in the network mask of 255.255.255.0, and then you got to tell the clients the address of their gateway, so you type default router 10.0.5.1. That's the sub-interface address. Okay. If you want, you can assign a DNS server, just so you see how it looks like, 10.0.5.1. Hit enter, and then type exit, and then from global configuration mode, you type IP DHCP EX, hit the tab key. It'll fill out excluded address for you. We want to exclude addresses 1 through 10. Okay, so the first address in the pool that's assigned is .11. So we'll start with the beginning address that we want to exclude, 5.1, hit the space bar, 10.0.5.10. Okay? And then the last step is just to configure the pool for VLAN 6. So again, we can use the up arrow because all we need to do is change the 5 to a 6. So we hit the up arrow once, twice, 3 times, 4 times, 5 times, 6. Okay, until you get IP DHCP pool VLAN 5 and just type a 6 in there for the new pool. Hit the up arrow 1, 2, 3, 4, 5, 6. Change the network address from 5.0 to 6.0. Hit the up arrow 1, 2, 3, 4, 5, 6. Change the default router from 5.1 to 6.1. Hit the up arrow 1, 2, 3, 4, 5, 6. Oops, I did it too many times fast, so I hit the down arrow. And I changed for the DNS server, change it to 6.1. Okay, and then I need to type exit. And my excluded addresses, okay, I can't use the command history recall when I go back to global config mode. So I'm going to have to manually type that in. IP DHCP EX, hit the tab key, fills the rest of it out, and then type 10.0.6.1 space 10.0.6.10 and hit enter. Okay, and that completes the router configuration. There's nothing else we need to do on the router. Okay, now from here we can minimize the router window, and what we want to do is click on each PC, and we want to, under IP configuration, we want to click that DHCP button. Okay, and you should get an address. Like first one grabs an address of 5.11. Okay, you can minimize these windows and click the IP configuration window and click DHCP. This should get an address of 6.11. Okay, and then you go to the PC0 and go to IP config. And all of them should be able to grab an address. So I'm just doing that. And notice they're in different VLANs, right? So they're grabbing them from different pools. Now the PC's at the bottom. Two more to go, right? It's a lot easier than manually typing in the addresses. So you get to see how actually DHCP works. That's one of the benefits of you know, when you have hundreds and thousands of computers trying to manually keep track of them and assign IP addresses to them, and making changes would not be feasible. Okay. So when you click on that DHCP button, that's analogous to coming into work and turning your computer on in the morning, right? And your computer's a DHCP client, and it grabs an address from a DHCP server from the pool. Okay, so we have our configuration set up, right? And we have a spanning tree domain, okay, in which we have VLAN 5 and VLAN 6. Okay, now how would you know which one is the root switch? Okay, well, if you know your topology, and I'll give you an example. First of all, you need to understand what a root port is, what a designated port is, and what a blocking port is. Okay, so a root switch, all its ports that are participating in the switching domain, okay, not the access ports, not 5 and 6, but 1 and 2 and 3 and 4. A root switch, all its ports will be designated ports. They'll be in the forwarding state. They'll forward updates and bridge protocol data units out to other switches in the domain. They're like the person in charge of the meeting that we talked about earlier. Okay, a root port it's confusing, right? But a root port is assigned to a non-root switch. A root port means that if you see a port and it says root port, it means that that port is directly connected to the root switch. Okay? So you'll see root port, and we're going to go over these commands in a second. You'll see a root port. You say, okay, I immediately know that this is not the root switch, but this switch on this port number is connected to the root switch. Okay, so again, a root switch, all its ports are designated ports. Switches 0, and let me turn off the port numbers here briefly, and this should be switch 2. Switch 0 and switch 2 are going to have root ports because they're directly connected to the root switch. Now, which ports are going to be the root ports? Well, you notice on port 4, you see an amber light, and on port 2 on switch 0, you see an amber light. Those ports are in blocking state, right? They're there to prevent the switching loops that we talked about earlier, while ports 1 on switch 0 and ports 3 on switch 2 are going to be root ports, letting you know that yes, they can receive a bpdus, but that port is also directly connected to the root switch. So knowing your topology, you would automatically know that switch 1 would be the root port. Okay. Now, if you go to the switch at the bottom, it's switch 3, and you don't see any root ports, right? And you see some designated ports and some blocking ports, you know that switch 3 is not directly connected to the root switch. Okay. Well, how do you determine which switch is root? Okay. So we're gonna go over some commands. We're going to go ahead and click on switch 1, and we're gonna log in, and we're gonna do some spanning tree commands. We're gonna type enable. And again, we're on switch 1. We're going to type the command show spanning tree, and we're going to do VLAN 5 first. Remember, spanning tree it's on a per VLAN basis. So you got 2 separate spanning tree domains for VLAN 5 and VLAN 6. You could actually split the workload. If you wanted another switch to be the root switch for VLAN 6, you could do that, where one switch is the root switch for VLAN 5, and another switch is the root switch for VLAN 6. Okay, so let's just hit enter. Okay, and let's look at the output of the command. Okay, well, first of all, the first thing you see is the root ID. It gives you information about the root switch, and how do the switches determine which switch is going to be the root switch? Well, they look to the lowest priority number first, okay? And here's the thing, in spanning tree, by default, when you take switches out of the box and plug them in, they all have the same priority number, right? So they got to look to a second thing, right? What's the second criteria, okay? You know, it's like judging a contest. You know, who's the best guitar player? You know, first criteria is who's the fastest. If they're both fast, we got to look at the second criteria, who's more creative, right? So there's criteria involved, right, in the election process. Well, the first criteria is the priority number. The lower the priority, right, then the switch with the lowest priority will become the root switch, okay? And if they all have the same priority, then the second thing they need to look at is the one that has the lowest MAC address, right, on their port. So you can tell this switch is the root, okay, first of all, because it's telling you, when you see this bridge is the root, it's letting you know that switch 1 is the root. But there's another way you can tell. It's giving you the MAC address of the root switch, and then the bridge ID is the specific information on switch 1. And the MAC addresses are exactly the same. So here's my lowest MAC address, and here is the lowest MAC address for the root switch, and they're the same. So it's telling you that switch 1 is the root switch for VLAN 5. Okay? Again, the root ID tells you information about the root switch. If you see this comment in here, it's letting you know this switch that you're specifically logged on to is the actual root for VLAN 5. But again, there's another way you can tell. It gives you the MAC address, lowest MAC address of the root switch, and then the bridge ID is information about your switch, and the MAC address is identical. So there's two ways you can tell that this switch is the root for VLAN 5. Now look at all the ports, right? You could see on a root switch, all the ports will be designated ports. Okay, that's another way you can tell that this switch is the root for VLAN 5. Okay, now we're going to do the same command, but we're going to hit the up arrow and change VLAN 5 to VLAN 6. Okay, and again, you're getting the same information. So this switch happens to be the root switch for VLAN 6. Okay, so again, we did not change the priority numbers on these switches. So by default, they all have the same priority. Okay, and so if they all have the same priority, they got to go to the next criteria, which who has the lowest MAC address. First criteria, lowest priority. Second criteria, lowest MAC address. Okay, and so it's kind of like a Cisco cert exam question. Let me go back here. I clicked off it. And again, it's telling you that this switch that you're looking at happens to be the root for VLAN 6. Another way you can tell is the MAC addresses are the same. That's the second way you can tell. The third way you can tell is all the ports are designated ports. Okay. Now, if you know this switch 1 is the root for VLAN 5 and VLAN 6, then you know that when you look at switch 0 and switch 2, they're going to have root ports because they're directly connected to the root switch. They're going to have some blocking ports and some designated ports. So let's look at switch 0 and let's log in. Oh, I didn't want to go that far. Let's go back to user privilege exec mode and type show spanning -tree VLAN 5 and hit enter. Okay. So again, it's giving you information about the root switch, which is the same MAC address that we looked at on switch 1, right? Now this is information about your switch, about switch 0. Notice the MAC address isn't the same, and you could see it has a higher MAC address because if you look to the second octet here, right, they both begin with 0001, but the root switch has a 6 in the second octet, and this one has a 9. So right off the bat, you know that this switch has a higher MAC address. The priority numbers are the same, but this MAC address is higher, so it cannot be the root switch. But you know it's directly connected to the root switch because it has a root port. Okay? And so port 1, you could see, you could barely see the 1 in my topology, but it says, like if I can drag this around, it's just not allowing me to do that. But port 1, okay, has a green blinking light. Okay, and so port 1 works, but it's the root port. It's directly connected to the root switch. Okay, and which port is being blocked? You see an amber light on port 2, right? So on port 2, it's telling you that port 2 is in blocking mode. It will not receive any bpdu's or updates. And again, that's to prevent the endless loop that we talked about earlier. Okay. Now ports 4 and 3 that are downstream and are pointing to switch 3 at the bottom, right? Both lights are blinking green. Those are designated ports. Okay, so whenever you see a root port, you know it's not the root switch, right? And so that's one way to tell. And of course, the MAC address here is higher than the MAC address, lowest MAC address on the root switch. Okay, now I could do the same thing for VLAN 6. I'm pretty much going to get the same information. Okay, so again, port 1 on VLAN 6, right, is the root port. One of them is in blocking mode. Port 2 is in blocking mode, right, with the amber light or orange light. And again, you could see that your switch that you're logged onto has a higher MAC address than the root switch. Okay, several ways to tell. Now, you can do the same thing on switch. This is switch 2. So we'll do this real briefly. And we'll do show spanning tree. And we'll type VLAN 5. And again, we're kind of getting the same information, right? So in this case, port 4 should be the blocking port because you see the orange light. I think I was calling it amber for some reason. I don't know if that's the right color, but orange light lets you know that port 4 is being blocked. Okay, port 3 is actually the root port because it's receiving BPDUs, but it's also connected to the root switch. All right, and so you verify that. Bring this up. So your port 3 is the root port, and the downstream ports are both designated ports. Ports 1 and 2 are designated ports. Okay, so with that said, right, the switch at the bottom is not going to have any root ports, right, because it's not directly connected to the root switch. So all it's going to have is some ports that are in blocking state, right, and it's got to have at least one designated port so it can receive BPDUs from the root switch. Okay, so you want to make sure that it has at least one designated port for VLAN 5 and VLAN 6. So again, we're on switch 3, the switch at the bottom. We go enable, and we do show spanning tree VLAN 5. Okay, and as you can see, well, it's got port 3 as a root port, but 1, 2, okay, port 3 is 1, 2, 3. It's the one connected to switch 0. So let me look up the definition of a root port. Okay, everything else looks good. Everything else is being blocked, like ports 1 and 2 are in blocking state. Which one is port 3? It's the one that's, okay, port 5. Okay, I see what's going on. All right, so basically what we need to do is let's look up where the root port is. What is a root port? Okay, so slightly off of my definition. It's the port that's closest to the root bridge. Okay, so again, you're going to have a port that's a root port. And I kept saying directly connected, but it's actually a port that's closest to the root switch. So given this topology right here, and that both ports 1 and 2 are being blocked, right, then obviously if these two ports here are being blocked, then the port 3 is going to be the root port, and it's the port closest to the root switch. Okay. So with that said, if we go to VLAN 6, okay, you're going to get the same information, right? You're going to get ports 1 and 2, which are in blocking state, port 3, which is the root port closest to the root switch, and that is on FA03. And what we're going to do is we're going to do a couple of things now. So we have a root switch, which is switch 1, okay? And what we need to do is we want to set up a spanning tree domain in which we would like switch 0 to become the root switch if switch 1 were to fail. And if switch 1 and switch 0 were to fail, then we would like switch number 2 to be the root switch. So we want switch 1 to be the root. We want switch 0 to be the first backup. And we want switch 2 to be the second backup. And we can do that by changing the priority numbers. Okay? So again, they're using the lowest MAC address since all the priorities are the same. So what we want to do is give switch 1 the lowest priority number, give switch 0 the second lowest priority number, and give switch 2 the third lowest priority number, and we'll leave switch 3's priority number the same. We never want it to become the root switch. Okay? So what we're going to do is we're going to click on switch 1, and we're going to go to global configuration mode. And we have to do this on a per VLAN basis. So we have to type the command spanning -tree, I believe it's priority, or no, I think it's VLAN 5. Hit the question mark, yep, and then you type priority, question mark, and you got to set it in increments of 4096. Okay, so you got to add 4096, got to keep adding 4096. So we're going to give this the lowest priority, and we're going to give it 4096 for VLAN 5, which still makes this the root switch. And we're going to hit the up arrow, and we're going to change VLAN 5 to VLAN 6. And then we're going to go on switch 0. And we're going to type config T. We're going to type spanning tree, VLAN 5, priority. And you got to keep adding 4096, right? And I believe if you add 4096, you get 8192, right? Which would make it the second lowest priority. Hit enter. Hit the up arrow. And hit enter. Okay? And then you want to go to switch 2 here on the right side, and you want to go to global config mode, and then you want to type spanning -tree VLAN 5 priority, and I think it's 1288. If you have 8192, 8192, I think that's it. We'll hit enter. It'll tell us if it's wrong. Actually, it was right. Okay, so my math was right. So it's 12288. Hit the up arrow and change VLAN 5 to VLAN 6. Kind of testing my math there. All right. So with that said, what we have is switch 1, which is still the root, has the lowest priority number. Switch 0 will be the backup because it has the second lowest priority number in the domain where switch 1 were to fail. And if switch 1 and 0 were to fail, switch 2 has the third lowest priority number. It would become the root, while switch 3 would never become the root. Okay, so there's other ways we want to ensure that switch 3 could never become the root, or we accidentally replace switch 3 with another switch or a rogue switch, and hackers have done that. So imagine you could bring a switch into work, unplug PC2 from VLAN 5, right, and plug it in, and then you have another switch here and participating in the switching domain, and it could send out bridge protocol data units in which it has the lowest priority number and make itself the root switch. Well, there's two ways you can do that to prevent that, okay? First thing is you can implement what's called bpdu guard, and you implement them on access ports where the PCs are connected. And that is that on these access ports, on port 5 and port 6, right, you will not allow bridge protocol data units to be received on those ports, right? PCs are connected to these ports, and so even if somebody were to bring a rogue switch into work and plug it in, into port 5, and that switch begins immediately sending bridge protocol data units, port 5 would not accept those bridge protocol data units. Okay, so again, the definition, it's a security feature that prevents unauthorized devices, such as switches instead of PCs, from accessing the network by blocking bridge protocol data units. BPDUs are messages used in spanning tree protocol to help create a loop-free network. Also, they're used in the election of the root switch. But again, like we were saying before, they can be used for malicious purposes. So we can go on ports 5 and port 6, and we can implement bpdu guard. Okay, so to do that, you go to switch 0, right? And you can use your interface range command, F0/5 dash space 6, and you could type spanning tree and hit the question mark, and you type bpdu guard. Okay. And that's it. No, you got to type an enable afterwards, I believe. Yeah. And then you type enable. Okay. So if you want, you can copy that. You can go to your notepad document and do an interface range command. We said 5 and 6, right? Which are our access ports. Paste in your bpdu guard. You can highlight this, copy and paste it into the other switches. So we click on the switch at the bottom, and you got to be in global config mode. So we got to type a config T, and then do a right click with your mouse and click paste and hit enter. And do that for each switch, even on the root switch. Okay, so you implement bpdu guard on the access ports as well. Okay. Now you want to set up what's called root guard. Okay, so we want to prevent unauthorized switches. What's the only unauthorized switch in our switching domain? It's the switch at the bottom, right? Because switch 1 is the root, switch 0 is the first backup, and switch 2 is the second backup, and we never want switch 3 to become the root. Let's just say it's an older switch and it doesn't have the same type of memory and processor capability as the other switches, so you never want it to become the root, and you never want to accept bridge protocol data units on ports 3 and 4 on switch 0 and on ports 1 and 2 on switch 2. You don't want to receive BPDUs from switch 3 saying like, maybe I have a lower priority number, new election, I'm going to be the root. You want to prevent that. So spanning tree root guard, again, is a security feature that prevents unauthorized switches, switch 3 at the bottom, from becoming the root bridge of the network. Okay, so what that means in English is you want to reject any potential bridge protocol data units from being received on switch 0 on ports 3 and 4 and on switch 2 on ports 1 and 2. You don't want to accept any, if you look at my mouse, you don't want any BPDUs being sent from switch 3 to switch 2 and from switch 3 to switch 0. So on ports 3 and 4, we want to enable spanning tree root guard. And so we'll go ahead and click on switch 0, and we'll use our interface range command. We'll type int range F03 space dash space 4, and you'll type spanning tree, and I believe it is guard question mark root. Okay, and so that's the command. You can copy it if you want and just paste it onto the other switch. You go to switch 2 on the right, and we'll go use our interface range command. Now again, on switch 2, it's ports 1 and 2, so we go interface range, FA or F0/1 space dash space 2, and you can right click spanning tree guard root. Oh, for some reason I didn't copy the S over, so I got to type an S, right click, and go paste. Okay, and that enables root guard, and that prevents switch 3 from ever becoming the root switch, because as it sends BPDUs, ever saying it has a lower priority number, like of 1, for example, which would be lower than switch 1, those BPDUs would be rejected by switch 0 and switch 2. Okay, and there would be no election process. Okay, so that completes BPDU, that completes root guard. And we've looked over spanning tree in detail. So again, let's define the terms. A root switch in a switching domain is the one where you send all your traffic to, right? And then it sends traffic to everybody else to ensure a loop-free switching domain. Again, like the leader of the meeting that we talked about earlier. On a root switch, all its ports will be designated ports, okay? On all non-root switches, right, you'll have a root port, which is defined as the port that's most closely connected to the root switch, okay? Blocking ports on not root switches are used to prevent the switching loops that we talked about earlier, okay? We enabled BPDU guard on access ports, so nobody could ever unplug a PC and connect the switch to port 5, for example, on switch 0, making that switch part of the switching domain. Okay, that would be prevented. And we also implemented root guard, so switch 3 could never become the root switch in the switching domain. Okay, so the last thing we want to do as far as switch security is you always want to make it as a good rule of thumb to turn off unused ports. Okay, now on the switch 1, we're using the gigabit 01 port. Okay, that's connected to the router. But we want to shut off the gigabit 02 because it's not being used. So we type interface G02, and then you could just type shut. Okay, you're just shutting down unused ports. Okay, now on switch 0, switch 2, and switch 3, we're not using any of the gigabit ports. So you go interface G01. You use your interface range command, interface range G01 space dash space 2, and you just do a shut command. Okay. And likewise, you do the same thing on switch 3, interface range G01 through 2, and just do the shutdown command. Shut both the gigabit ports down, and likewise do the same on switch 2 on the far right, and go interface range G01 through 2, and just type shut. Okay, last thing you want to do is shut down all unused access ports. So if you recall, we're using ports 1 through 4 for trunking. Okay, we're using ports 5 and 6 for VLAN 5 and VLAN 6, and we want to shut down ports 27 through 24. So I'm doing this on Notepad, interface range F7 through 24, shut, right? And I can just take that and I can copy that. So I'm shutting down unused ports, and I'm locking down the switch security in the domain. So I click on switch 1. Like if I point my mouse over the switch, I see that ports 7 through 24 aren't being used and they're assigned to VLAN 1. Okay, now if I was to plug something into that port, that link would come up. Okay, but I want to administratively shut them down. Where the only way that port's going to work if I administratively go in the console and turn it on with the no shutdown command. So I'm going to just do a paste and hit enter and shut down all the unused ports for each switch. All right. So that completes the lab. You want to save the file, right? Upload it in the assignment area. And of course, if you have any questions, just let your instructor know.